Okay guys, here's what I'm doing. I'm in the process of wiring all this up, and I've already taken the liberty to do a few things to show you where I'm at versus just keeping on the camera running and making a long boring video. So let me show you what I currently got going on. So if we look inside here, this is the transformer that is going to power up my DC converter bank here. And then I've got the signal tracer here, and I have connected the wires to the speaker. And then besides that, these are the power wires for the signal tracer, and they're going to go over here to my 9-volt power source. And then I have my dummy load right here, and I've labeled it because it's going to go right about here, and then I'll know which ones are which. I'll have to connect those wires up, which are that bundle that you see there in white running over there. I didn't know how long I was going to make them, so that's where I made them. Once this is mounted in place like right here, then I'm probably going to put the DC board in front of it, like right here, because I shouldn't have to get into it. If I do, it's just going to be accessible through the back. A couple of screws, I can move this out of the way. I don't foresee any problems going on with this anytime. I think those 100-watt resistors are going to last indefinitely, so I think putting it back behind the converter board's fine. So I'm going to do that, and then we'll come back. Okay, so I've got the dummy load all installed, all wired. I've got the wiring for this transformer wired in place, and so now I'm ready to get the DC converter board on here. I'm going to mount it right up front here, right like that. That should work quite well. I'm going to have to shorten the wires here. Obviously I didn't know how long I was going to need them, so I left them really long, so I'll leave enough to make a nice loop, but that should be it. So let me get that done and we'll come back. Okay, if you guys can see that, I got that all situated in there, and right now I'm running it off of my Variac. Getting ready to hook up the signal tracer to the 9-volt right here. Alright, now I've been doing some wiring, and one of the things I've been doing as I've been wiring is I've been updating my little schematic prints that I made, so that when I'm all done I can create a new schematic with all the wire colors on already. So for future reference I'll have it. What I've been doing really is wiring this biggest strip right at the moment. So this is the switch that turns on this transformer to power up this converter. And these are the wires that are going to go over to the converter. And I've used, as you can see, I've used the wiring from the wash machine. Worked quite well. Got enough wire colors that I can separate them out and have them make some sense. And then I've got over here, this is the AC/DC switch. And I've got, of course, the black and the red for the DC out. And then I've got white for the neutral and brown for the AC in. And I've been labeling things as I go. I want to show you what I had here. Now this obviously is nothing, that's just sitting there. But I'm getting ready to go ahead and stick this in the MFP, which will go in through there, but I wanted all my wiring attached because I didn't want to have to work inside there. I'm still going to have to work inside there some for this wiring, but I can reach this pretty good, I think. But getting into that stuff and those switches was going to be a real pain. I actually have the other end of this switch wire right here that goes to that transformer, and I'm feeding it out the front, so when I rotate this around I can put it on the switch and then I can cram everything in there and screw it down. So let me get that done and we'll be back. been working on the wiring back here. Basically, everything from here, which this is the component tester here, over is wired. The only thing left for me to wire is the transformer, the condenser filter, and the variac. If you look inside there, you can see the signal tracer in there. The signal chaser is not in there yet. The wiring for that is the only loose wiring. You might see a couple of wires left down in there laying. That's for that. All of the jacks are wired for the DC-DC regulator boards here. And right now I've got power hooked up here and here. This is the neutral. This is the hot. These are the wires that will be going into the output of the electronic circuit breaker. And then, as you can see, I've got them marked. This one here is going to be the power that supplies AC-DC switch for whether it's going to AC or whether it's going to the transformer. That's that switch. And then this one here, this is positive ECB. This is the one that powers up this side of the multifunction panel. Okay, so let me flip this switch and we'll take a look at the front. Let's see if you guys can see the meters. When I flip the switch, this is the switch that controls all these DC outputs, as well as these two meters. And there you go, and they're working. So I'll come back around here, take a look at the DC-DC converters. Everything's lit up. The top one's the 4.0, that's for the component tester. The bottom one's the 3.2, that's for the DMM, as well as the 3.2 output. And then we've got a 9 volt, and we've got a 12 volt and a 6 volt. All those can be adjusted however I want them, except the 3.2 and the 4.0. Obviously those are unique to those two meters. That's where we're at right now. Alright, so my next thing I'm going to do is start working on right in here as far as the DC bridge rectifier assembly for the transformer and the variac. I actually had comment on my last video where a gentleman suggested that I not use that plastic box I built to house my filter condenser bridge rectifier because he was concerned about those 2 resistors getting too hot. I don't think they're going to get too hot. I really don't. But I may rethink it anyway and redo the cabinet piece of it. Maybe open up the end where those resistors are and put like a metal guard or something. Or I may just make a metal bracket. It's getting kind of tight in here anyway. I'd like to have it down back behind there, but I think my box is too big to fit in there comfortably. So it might be better just to mount it on a small metal bracket anyway. So we'll see. I still have to get the ECB board, but I've got the ECB board bracket designed so that it can stand vertical. And it'll still leave me room to get the signal chaser in there. So let me get started with that and I'll bring you back. So let's see where we are right now. And one of the things, I don't remember if I told you before earlier, but these 4 wires right here coming up out of this are for the variable power supply that's going to sit on top. They're all, it's all wired and ready to go. It's just need to go hooked up to the other board. So, transformer wired all up. I've got the rectifier DC condenser filter mounted in the back down there. It's now no longer in the box I made because it takes up much less space this way. Plus, a suggestion that was made to me to let the power resistors have a little more breathing space. I think that'll work fine. I've got the output of the variac hooked up. And really the only thing I got left is to get these meters all figured out where all those wires are going to go for the AC amp and the DC amp and voltage. So I got that left to do, and I got the ECB yet to figure out and get installed in there, and that's what these little wires are here for the various indicator lights. I've got a neutral out for the ECB, I got a neutral in for the ECB, I got a power out from the ECB and a power in from the ECB. So ECB is kind of where we're at right now. So I wanted to show you guys, I did fuse it. There's the fuse down there, and then we've got the power cord right here. That will plug into the isolation transformer. So we're getting down to the nitty-gritty in New York City on this one. Let me come back when I get the rest of it wired up, or at least the ECB in place. Hey guys, I'm getting ready to get back on the ESB board. I got the additional parts that I needed. I wanted to show you this Yaihua, I think it's pronounced, cheapy soldering iron kit that I bought so that I could have another soldering iron at the other bench in the other area of my shop, and it came in. And so it's here, and I was going to show it to you. I'm actually pretty impressed for the price. I mean, I keep my Weller in here. That's the Weller up there, and I love that. But I think I paid about 160 bucks for that. Now this Yaihua I got on Amazon was only 43, I believe, 43.99. I think it's the 926 model, if I remember correctly. I don't know if you guys can see that. It's probably not gonna focus very well. It don't give you the model number that I'm aware, though. No, it does. It does. I guess it does say 926. But anyway, I wanted to show you guys this. It's actually not bad. I've used it a little bit here, and it's not too bad. What I like about it the most is that it's got these adjustable arms, because there's so many times, there's one on each side, there's so many times I'm trying to solder two wires together. It's very hard, you know, you kind of twist them together and all that sort of thing, but it's like you need an extra set of hands. I like having the extra set of hands on here. I also like the fact that it came with a roll of solder and a solder holder, as well as a set of tweezers and additional tips and a wrench for the tips that are down in the side there, if you see that. Yeah, for $43.99, I don't know how long it's going to hold up, but I've used it a few times here now, and it seems to be holding up okay. But for $43.99, yeah, I like it. Not as good as the Weller, but heck, it's a lot cheaper than the Weller. So I'll use this probably in the other side of my shop. But for tonight, I'm going to go ahead and use it as I finish up the ECB board. Alright guys, let me show you what I got going on here. This is the electronic circuit breaker board. It's all together. I've got everything hooked up to it right now. It's outside of the MFP. This is just for setting it up the way I want it set up. So right now, if we look at it a little closer, you can see the pigtail jumpers here that go along with this IC, right? And part of that is the reset switch here and the cycle switch here. That's what all these leads are that are going to. This one is the current pot that I can select how much current where I want it to trip out at. I've got set up here, here's a ground wire. I've got my load here, which this load is actually going over to my variac right there, and attached to that I have my mixer, which thanks to Bob, you all know Bob, gave me the idea to create. I wanted to come up with 2 or 3 amp load because I don't want to go much higher than 3 amps. So that's what I got here. Right here I have my digital voltmeter, amp meter, watt meter for AC. I've got the power loop here. I've got this indicator light here is power on. This indicator light here is tripped. So what I want to do is fire this up and let you guys see, but let me get you on a tripod first. Okay, trying to get you guys where you can see the meter as well as the indicator lights. So that's what we're set up to do. I'm getting ready to plug it in. When I plug it in to normal power, you should see the gauge come on and the power indicator light come on. See if you can see that. Right now it's showing 122 volts and 6 milliamps of current, assuming you're seeing that. First of all, let me show you, I've got my current knob turned full because I want it to be full. Well, you can't see that, but right now you can see it. I got the current knob turned as far as it'll go, which is my maximum current that I want to achieve here. I'm going to set that there. I've got my cycle switch on the quickest cycles And so let me turn this mixer on, and we'll see what we got here. There's 2.27 amps of current, and it's running. As you can see, everything's still doing good. Now what I'm going to do is I'm going to hit this fast to apply a surge of current to it, and you can see what happened. It killed the circuit, and now the trip light's on. So I can now, without even really touching the mixer, because it was okay at the 2.34 amps. So I've got my trip switch here. I don't know if you guys can see this. I'm going to hit the trip switch, or the reset switch, not the trip switch. That's the trip light. This is the reset switch. And it restarts the circuit. We're back at our 221 amps. So what I can do, I've got my low side of this current so that it kicks out. If I have it all the way down to the low side, if you guys are seeing what I'm doing, I'm twisting this down. It trips out at about 180 milliamps. So the low side is 180 milliamps, and the high side is about 2.5 amps right now. I used 2 pots to set that up. This one and this one I had in place of R6 and R7 to get that set up. So circuit breaker's a success, and it is ready for me to put it into the MFP and get this MFP finished and finalized. I'll show you. I also created a mounting bracket for it right here. There's a mounting bracket. It's made for that. They have standoffs. I haven't drilled the holes for the standoffs yet, but it's going to be bolted there. I'll show you that before I put it actually in the MFP. But that is electronic circuit breaker. That's kind of what I was building this MFP around. So, okay, let's get this baby together. Okay, so I got the ECB mounted to the board. Did it with the nice little inserts here, so we got nice spacing. That's the way it's going to mount. I got 3 holes like that. It'll screw down into the wood base. I'll glue this down to the board. This runs up to the meter. This runs up to the meter. There's the cycle switch. I got plenty of wiring to fit that in there. There's the current pot. I got plenty of wiring to get that in there. And then I got to run my indicator lights. So let me get that all mounted in there and we'll come back. Okay guys, it's pretty much all wired up. I got the board in there. I had to put it in a little bit of a diagonal in order to clear the AC amp voltmeter, but it's okay. And as we look across there, I got my heat sinks on, the little DC-DC converters. What's going to go in this opening right here is the signal chaser. I haven't got that in there yet because I have it already in a case, and I don't think that case is going to fit in there. I may have to remanipulate it to get it to go in there. So for now, I'm not going to worry too much about that. This wire is a ground, not a neutral, but a ground that I'm going to be able to clip my ground lead to. But let me flip it around and see if this thing's going to work now that I got it all put back together again, or if I forgot something. So one thing I was going to show you is, here's the power cord for it, and as well as the power cord. And I have a main on-off switch for the entire panel. So I'm going to show you that. Now let me get it turned around. Okay, I flipped it around here. I've got my meter set on DC right there. We're going to go ahead and flip it on, the main power switch. We're going to flip it on. So I've got my indicator light for the main power switch on right now. DC just came up for this particular meter. my amp meter, I think, has gone bad. I don't know if you can see this or not. I don't know if the light's showing this. It might be too bright in here, but it's flashing. It was working when I originally hooked this up. It's not working now. I went ahead and unplugged it, and I have 9.5 volts to it. So it's not an input or neutral issue. Same feed feeds this, it feeds this. And with that plugged in, I had my correct voltage to it. So I think that this amp meter has gone bad. I'm going to have to order a new one. What I was going to show you is our little DC supply here. So this is the switch for this. This is going to turn on my DC converter bank. So that should power both the DMM and the component tester when I do that. And it does. They're both on. And because I've got my negative on the common here, I should be able to take my positive and go at each one of these, except for this one because that's the variable and it's not hooked up yet. And we should be able to get some reading here. So there's 3.27. That was the one that's supposed to be set to 3.3. There's a 6.15. That one was set to 6.2, I believe. That one's 8.92. I think I had that one set to 9 volts. I might have to turn it up a little bit. This should be the 12 volt. And we're 12.12. So all of those are working properly. This is a signal chaser. It's not in there yet. I don't have it wired yet, so you flip the switch on, you're not going to see the indicator light. And that's the B and C jack out. This is the actual signal tracer. If I flip that on, so that's going to work fine. I don't have my lead on there, but at least I know that it's working. It's coming through the speaker. It has a little bit of hum, which doesn't shock me with everything going on around it, but it should still work as far as the purpose of it. Okay, so now let's flip on the ECB. It came on. It shows tripped right at the moment, so we'll untrip it. That's the pilot light right now. So if I turn this thing, I don't have any thing hooked up to it from an amp standpoint. Got it on DC. Let's put it on AC. Okay, so what I wanted to show you is this electronic circuit breaker and the capability that it has. So right now I've got this variac, AC variac turned all the way down. I've got this little glue gun plugged into my outlet right there. I've got the electronic circuit breaker on. This is the pilot light that shows me it's on. And this is the pilot light for the entire unit here, okay? So not to get confused. This is the trip light that will come on when it trips. Now right now I've got this set at the lowest current, which is approximately 150 milliamps, 120 milliamps, I think. About 110 to 120 milliamps. So it's as low as it'll go. Right now we got 20 milliamps. As I start increasing my current with my variac, you'll see the current start raise on this, because this is on. There's 30, 40, 50, 60, 70, 80, 90, 100, 10, 110, 120, and it just tripped. And you can see that everything's dead now. There's no more current being supplied because it just tripped. Okay. Now, if I turn this up some to where it would be able to handle the 120, I can reset it. Now it's reset back up again. Pilot's on. There's 110, 120, 130, 140, 150, 160, 170. But if I turn it back down here a little bit, there it goes, it tripped. So circuit breaker's working exactly like it's supposed to, and as I showed you guys a little bit ago earlier when I had the mixer on there, it's tripping out at about 2.5 amps on the high side. So my current here is basically going to go from about 110 milliamps to about 3 amps from when I turn this all the way and all the way back. I wanted to demonstrate that. What I want to do is get this meter. I've obviously not quite got it wired right because I'm reading my voltage in to the unit versus coming from the variac. It's showing the amperage properly, but it's not showing the voltage. And maybe I can't do it with this setup. I'm not sure. I am pulling the power for the meter and the load through the electronic circuit breaker. So maybe it will only show the power that the breaker is supplying to the variac, or I may have the wrong wire plugged in the wrong spot on the variac. I'll take a look at it. But I did want to show you guys the electronic circuit breaker and why that is so cool and why it's going to be perfect for this setup. We can go ahead and reset it like that. It's reset, current back, and I'm going to have to get me a new meter ordered for that amp meter. I'll turn off the circuit breaker, kills the power, goes turned off, and then shut off the rest of it. Okay, now I've got some decals that I've made that I'm going to start putting on the unit because I got to do something to finish this up. This is the sheet that I printed out of the decals. This is clear vinyl, self-adhesive, and I did it on my laser jet. So I've already got some over on the one side. I don't know if you guys can see that or not. I want to put on there right there. So anyhow, let me get started on making the wood for the back.